Okay, taking a look at the homework I sent you for Chapter 19, Question 1. The question is asking us to consider the production of methanol here from carbon monoxide gas and hydrogen gas. It gives us the initial concentrations. For carbon monoxide, it's 1.75 molar. For hydrogen, it's 0.80 molar. And for methanol, it is 0.65 molar. It says once we let the reaction proceed towards equilibrium, we find that the ending concentration of carbon monoxide is 1.60 molar. Okay. So now it wants us to find the equilibrium constant for this reaction the way it's written. So if we look at what we have for the ending, the difference between the beginning concentration and the ending concentration of carbon monoxide is going to be our change. Well, 1.75 minus 1.6 is a difference of 0.15 molar. So since it's a 2-to-1 ratio for this carbon monoxide and the hydrogen gas, well, we're going to see the change for the hydrogen gas is going to be a minus 2 times 0.15 molar, which is the same as 0.3. So 0.8 minus 0.3 is going to be 0.5 molar. So if we saw a difference of minus 0.15 molar for the carbon monoxide over here, and it's a 1-to-1 ratio with the production of carbon monoxide with the production of methanol, if it was negative 0.15 on this side, it's going to be plus 0.15 molar on this side. So 0.65 plus 0.15 molar is going to be equal to, 0.8 molar. Okay, so now we found our ending concentrations at equilibrium for carbon monoxide, for hydrogen gas, and for methanol. Now, using this information, we're going to find what our K is. So it's products, which is methanol, over reactants. And hydrogen, in the case of hydrogen, is going to be squared. So let's find out what that is. So it's going to be 0.80 over 1.6 times 0.5 squared. If you plug that in your calculator, it comes out to be 2.0. This would be your unit here. So this is the answer for number 1 on your homework. Number 2 gives us this chemical equation. We have N2O4 is in equilibrium with 2NO2. We are given K, which is 0.2 molar. It's saying that we are injecting 2 moles of N2O4 into a 1 liter reaction container. Therefore, our concentration is going to be 2 molar, right? It's 2 moles over 1 liter, easy enough. So and this is at 100 degrees Celsius. Okay, so now we're going to find our change. Well, let's see. We have 0 on this side to begin with. So our change on this side is going to be minus x. So therefore, at equilibrium, it'll be 2 minus x. And this side, it'll be, well, it looks like it's going to be 2x. And then the change, it'll be plus 2x. And then over here, it'll be 2x at equilibrium. So now we can use this information to set up our K expression. So Kc is going to be equal to the concentration of NO2 squared over N2O4, which is going to be equal to 2x squared over 2 minus x equals 0.2. Okay, so the first step we can do here is multiply the 2 minus x out. So if we multiply both sides by 2 minus x, we're going to end up with 2 times 0.2 is going to be 2 times 0.2 is 0.4 minus 0.2x. Now we can take care of the left side of the equations. Be 4x squared minus 0.4 plus 0.2x. Okay. So if we set this equal to 0, now we're ready to solve our quadratic formula here. So remember, the quadratic is going to be, so here we have A, here we have B, and C. So the quadratic formula is opposite of B plus or minus the square root of B squared minus 4AC all over 2A. If we plug this into our calculator, what we're going to end up with two values of x. So in the first case, x is equal to 0.29. In the second case, x is going to be equal to 0, or negative rather. So it's going to be negative 0. It's going to be 0.34. And that's molar. Okay, so the negative doesn't make sense in this case. So we're going to reject that answer for x, and we're going to take the 0.29. So if we take the 0.29, well, we got 2 minus 0.29. Well, 2 minus 0.29 is equal to 1.71 molar. Here we have 2x, so 2 times 0.29 is equal to, let's see, 0.3 times 2 is 0.6, so it'll be 0.58 molar. And these are our final concentrations. So at equilibrium, you would end up with 1.71 molar N2O4 and 0.58 molar NO2. And this makes sense because Kc is pretty small for this reaction. So you would expect to see not nearly as many products as reactants that we started with. Okay.